Good afternoon. I'm Pam Schaff. I'm the director of the Humanities, Ethics, Art, and Law, or HEAL program, and the Narrative Medicine program here at USC. And I'm thrilled to welcome you to the 8th annual Artist and Researcher Show. This is our third year of partnering with Roski, and we're so excited to hear from all of the pairs about their work and get a chance to visit and enjoy this beautiful exhibit. I'm going to turn things over to Ted Meyer, our artist in residence, who will give you the history and the background of how this came to be, and we'll go from there.
Hi, everybody. Thanks for being here. So this show started because I have a really rare disease, and the research to come up with a treatment took about 36 years. So I know that the researchers spend a lot of time in their labs, in their cubicles, and I thought we should celebrate them and get them out of their cubicles and give them a nice meal once a year. So that's tonight. So you guys are all helping with that celebration. And what we're going to do tonight is Eric will speak in a second, and then we're going to have each of you stand by your piece and go around with each team, if both members are here, and have you talk for about 1.5 minutes, 2 at the most, about your piece. So thank you all for being here. The work looks great. As always, I'm impressed by the variety of mediums and styles that you guys came up with. It's just great.
And I'm just here to introduce the cohort for this edition of Artist and Researcher. I teach this as part of in a class called Design 430 Collaboration. They're the stars of this show, so I don't really have that much to add, except that I'm always, one of the reasons I teach, people ask me why do I teach, is that I get to share some time with these brilliant young people and see what they do. And as always, I'm very impressed and proud of them.
Thank you so much. So I think what we'll do is start at this side, and if you could have artist and researcher pairs at each of your areas when we get to you. As Ted said, about 1.5 minutes total, so we can hear from everyone.
Hello guys, I'm Aaron. Lung cancer takes away more memories of loved ones, and for this project I worked with Diego Velarde, a PhD student studying small cell lung cancer, where less than 10% of people survive. About 15% of patients naturally produce antibodies that help them fight the cancer and live longer. Velarde's team gave mice small cell lung cancer, making them produce these antibodies, and now they're working to modify them for human use through injection. And this is how they aim to improve survival outcomes for all patients. For my design decisions, the flat line represents how they're using mice to help them bring more life back to these patients, and the silver paper is there for viewers and smokers to reflect on how their decisions affect their loved ones.
Hello, my name is Rachel, and I collaborated with Dr. Zhanghua Chen. Wildfires have long been a defining feature of the California landscape, but their increasing frequency and severity pose challenges for public health and environmental safety. While much attention is given to the immediate destruction caused by fires, the loss of homes, landscapes, and lives, there's a significantly less awareness of their long-term consequences. The health effects of wildfire pollution persist long after the flames have been extinguished, infiltrating communities through toxic airborne particles and chemical contaminants. In collaboration with Dr. Chen, I have developed postcards with data visualization of the volunteers' activities before, during, and after the wildfire. I wanted to present this as a postcard to not only capture Dr. Chen's work, but to spread and share the message of her research. Thank you.
So for a lot of us, the hair plays a large role in our appearance, but a lot of us don't realize the internal and external factors that play a role in hair follicle stem cells and eventually the hair itself. So to stress this communication, I decided to create a subway-style map which represents the different pathways which are either hormonal, genetic, or stress-related that can affect things like hair thinning and hair loss.
Well, hello, I'm Dr. Martin Kast. I have spent the last 30 years of my career on designing therapies for cervical cancer, a cancer that is caused by human papillomavirus. And one way to prevent you from getting the cancer is that women will do their pap smears. And there is a reminder every year posted, and that is, and it's on the billboards. It says, "When the jacaranda tree blooms, it's time for your pap smear." And it blooms in pink. And your last name, Mecken, took that into account, and she made this interactive display. And if you are her size and you stand here, then you will see your uterus and cervix being displayed, and it will remind you that you have to get your pap smears. Sim?
Hello, I'm Sim. As Dr. Cass said, we collaborated on this project, and the idea that I had behind this project was a call to action for every woman that needs to get their pap smear. It's something that it's really important, that it's kind of has negative connotations within the society. And I just wanted to showcase the works that also can happen within cervical cancer, HPV, and if you stand in front of the mirror, unfortunately I'm 5'4", so I just kind of did it according to my size, and people like me, and if you stand in front of it, it's kind of a reminder for you to go and get your pap smear as well. Thank you so much.
Very well done.
Thank you.
I'm Julietta Momley. I'm one of the transplant surgery faculty at Children's Hospital and here at Keck Hospital. And my lab uses spatial biology and proteomic techniques to re-examine the biopsies that we perform on our patients that are required to diagnose rejection. And we're using this to help us identify new therapies and new biomarkers so we don't have to do as many needle biopsies.
Hello everyone, my name is Angelina, and so when I was first speaking with Dr. Mameli, I was really inspired by these images you can see here of her spatial biology work, and because she works with pediatric care, I wanted to do a paint by numbers piece because I think paint by numbers is something we usually associate as a children's craft, and I also wanted to make it interactive for the audience members to understand the collaborative aspect of understanding transplant success and failure. So I invite all of you, when you have a chance, to come fill out as many cells as you'd like. Thank you.
Hello, my name is Anthony Kabibi. I'm a research staff scientist in Dr. Selsa's lab in the Department of Pathology. What Prim here has effectively captured is the gut of a mouse that we have collected. These are technically called Swiss rolls, kind of an odd name, but they allow us to see the transition from a normal animal to a diseased animal, and ultimately how different treatments can affect the intestine that is being displayed here.
Hi, I'm Prim, and through Dr. Anthony Kabebe's work, I wanted to communicate how these Swiss rolls, even though they're in a microscopic level, can be very intricate when you put it in better focus. So that's kind of what I wanted to communicate through my piece.
Hi, my name is Arshia, and I'm a graduate student in the Developmental and Stem Cell PhD program. And my work focuses on understanding the stem and progenitor cells that form the skeletal and non-skeletal components of the craniofacial complex. And I'll let Sophia tell everyone a little more about the work she's done.
Hi everyone, I'm Sophia. So when I first started talking to Arshia, I started to understand more the key and essential role stem cells play in our body and how they are so important to our development and to our healing processes, how they are the base of everything and they transform to whatever our body needs. So this piece basically conceptualizes that. It tries to represent how a stem cell can become so many different types of cells and the different fates and destinations it has. The stem cells that are represented in this mix and match book are cells that are only present in the craniofacial region, which is the area that Arshia focuses on. And yeah, it's an interactive book as well. And obviously it's not, I'll show it a little bit. It's not based on like it conceptualizes the idea, so it is based on the cells, but obviously it is taking creativity and like showing how the base stem cell can become so many different types of cells. Yeah, and to do it, I used acrylic. This is just printed paper, but it was an amazing process to understand stem cells in a different way. And yeah, that behind the process of healing, it's not just magic and it's not just time, it's actually stem cells doing the hard work. Thank you.
Hi, I'm Calvin, and unfortunately Benjamin is not here today, but my project is about him traveling through the waterway and providing free healthcare with his teams. So this boat is representing Floating Doctor, his organization, and traveling through different areas, through like Mexico area and United States through LA. So there's like a lot of things happening with him and providing healthcare to a lot of undeveloped areas and regions. But I think hope he will be here, and he said he has seen my work, but it's nice to be here and nice to have him over here. Thank you.
Hello, everyone. My name is Son Young Lee. I'm a scientist from Lee Retina Lab. I'm also a retina specialist. So I remember as a medical student, I looked at every part of our body, and then I realized that the retina, the back of the eye, the nerve extension of the brain tissue was the prettiest part of the body. And I felt that I would not need a jewelry for the rest of my life if I can work on this. So I went through the training for science and then clinical parts. So I'm very lucky to be able to see this beautiful retina every day. Oftentimes they're all very sick, so Isabel will talk a little bit more about the sick retina, but they're still very pretty.
Yeah, so when I interviewed Dr. Lee, I was kind of moved by her passion for the retina's beauty. Yeah, so as a retinal surgeon and clinician scientist, right, you research diseases that cause vision loss. And so these are images sourced from the ASRS Retina Image Bank of diseased retinas, some including ones with age-related macular degeneration, inherited retinal diseases, diabetic retinopathy. And yeah, I basically just wanted to display them as the object of attention, kind of as a reflection of Dr. Lee's path into her work. Yeah.
Hi everyone, my name is Christian Liao. My partner here is Thomas Cho. And this is our piece right here, and it's about ketamine therapy and how it's an emerging treatment field and method that can help patients reconnect with nature and fight against deep mental disorders such as PTSD, OCD, and the like. And so the trust between patients and doctor is essential, yet stigma creates distance. And that's why misunderstood and overlooked, ketamine therapy offers more than its reputation suggests. It fosters connection, understanding, and a path to healing.
So, hi, I'm Thomas Cho, and in order to describe our art piece, it explores the doctor and patient relationship through ketamine therapy, and the trees symbolize growth, while vials inside, there are 10 vials with indirect and direct messages of treatment as nourishment. Illustrations connect healing to nature. Rather than reinforcing hallucinogenic stereotypes as mentioned, we present a grounded, organic visual experience, one that reflects the true restorative potential of ketamine therapy.
Thank you. This is my first time seeing the art, and I'm just so pleased to see that you got the essence of it, which was the connection with nature and humanity. So thank you so much.
Hi, I'm Sunny, and the researcher that I collaborated with is Roski, and she's not here today, but her research involves researching small cell lung cancer, and the research is severely hindered by mouse models that are too slow at developing their tumors, or they lack the immune defenses needed for meaningful results. So what she does is she injects mice either in the tail or under the skin, and this is to accelerate the tumor growth, and I kind of wanted to recreate that and make that into a tangible experience so the viewers can actually dig through the mouse and look for tumors themselves. but I feel like, I mean, through this method, she's making small cell lung cancer research more effective and great for testing new treatments. Thank you.
Hi, I'm Carlos, and the researcher I worked with was Dr. Du Yao, and I think she's not here. So she and her team was working on this web tool which helps to distinguish language development problems for bilingual children, especially for Chinese and English bilingual children, because there are not that much of resource out there for them to use. So therefore, she made this tool. And what I did is I reworked on the website, and I made 3 small animation and some visual changes, and also I give it a game system which encourages the children and help them to focus on the test, and hopefully they could finish the test and find out if they do have any language issues.
Hi everyone, good evening. My name is DJ Cast, and I'm the Director of STEM Education Programs over at USC's Joint Educational Project. And so we do a lot of science communication, and we have a staff of like 30 science communicators that are all undergrad STEM majors that are trained to teach science, and we are in 80 classrooms a week for 20 weeks during the school year. And so I'm a little bit of an odd duck between all of the like science researchers, but we provide the support to bring a lot of students of color into STEM fields starting at a really young age, and that's where Sammy came in.
So Dr. Cass and her team, like their efforts go beyond imparting knowledge. They are like reshaping a fundamental belief that STEM does not belong to a specific race, gender, or social class. So through the journey of a darker-skinned girl in my story, I want to show everyone that every child has the right to be an explorer. And whether you are a child, an educator, or someone just watching this today, I hope you can find resonance in the story.
Well, hello again. I'm the other Dr. Cast. You saw me presenting on the other side Sim Bacon's work on if you want to prevent cervical cancer, you have to get your pap smears as a woman. But there is another way of preventing cervical cancer, which is a vaccination. And the vaccine is called Gardasil 9. And that is the topic that Gigi Souza used. And she designed this beautiful old-style video game in which the harbinger of papillary venom, HPV, is being destroyed, and if you win the game, you survive.
Yes, so as Dr. Cass explained, I developed a video game as a means of, I guess, educating people about how vaccines work, specifically HPV, because it is super important for children to get vaccinated also. And yeah, I guess what really impressed me about Dr. Cass is he's very motivated to educate people, and I guess I wanted to help him create a means of communicating that.
And you did that very well.
Hello, everyone. I'm Danny Wang. I'm a professor at Stevens Neuroimaging and the Informatics Institute. We study the brain using all kinds of in vivo imaging technologies. Today, actually, Ella presented a piece that is both abstract and practical. I talk about, this is about the blood-brain barrier. It's a very elegant structure between the blood and the brain. It fills out a lot of toxic stuff, but also delivers the oxygen and nutrients to the brain.
Hi, I'm Ella, and then after learning about Dr. Wang's work, I decided to turn this complex concept into something that younger audience could understand. So
In this design, I want to showcase that the blood-brain barrier is kind of like a filter in your brain that stops certain harmful substances and only allows like the good ones to pass through. And this is more like an interactive piece where if you grab a handful of the marbles that's like representing the substance, and then if you drop it from the top to bottom, and then only like the small crystal clear one can be passed to the last layer. Yeah.
Only if you fit into the mold.
Yeah. Yeah, thank you.
Hey everyone, I'm Pete Mullen, and I don't want to be a downer, but we're all going to die. It's true, we are. And what our lab is trying to do is find out why we die in different organs, different organisms. And I just want to give a shout out because my lab's over there and they're the ones who actually do the work. And yeah, and Sarah, we chatted and Sarah came up with this really cool interactive exhibition and I'll let her tell you about it.
Hi, my name is Sarah, and based on Dr. Mullen's recent work on metabolic changes and aging in mice, I created an interactive AR artwork where you scan the QR code, and you click on each of the organs, you can see the changes that happen within the organ. Like some of them shrink, like almost disappear, some of them slightly grow, some of them are more active, some of them get less active, and I wanted to create an artwork that hopefully somewhat allows people to gain more interest on like the changes that happens inside our body, as like you can see the external aging process, but like you don't really know what's happening inside your body. So hopefully it is interesting, and if you want to learn more, you can read his research paper.
Hi everyone, I'm Winnie. I'm from the Dr. Bonagudi lab in the USC Stem Cell. I also don't want to be a downer, but we all gonna get old. But maybe before we die, we're gonna get old. But so when we get old, we get sick, and one of the interests that my work focus on is like loss in memory, learning and memories. So mostly I work on like how we can restore cognitions in patients with dementia or especially Alzheimer's disease. And one of the way that I'm doing that is to develop pharmaceutical therapy that target a stem cell population in the brain, which is very important for cognitions. But unfortunately, they become dysfunction with age. So that's mostly what my project is.
So one of the things that stood out to me when I was talking to Winnie about her project was her goal of translating the research that she does to real-world impact. And so using that as a departure point, I created a 3-part kind of basically a triptych here, and the left and right sides are 2 letters from a real couple affected hypothetically by the cognitive decline that Winnie's describing. So here on the right, you can see a letter from a husband whose wife is suffering with Alzheimer's, and on the right is her response. And so I would encourage you to come and read it more closely when you have time.
Hi, I'm Catcher Salazar. I'm a researcher at the Morset Lab in the USC Stem Cell building. And I research how we go from like a little ball of cells to us. And that involves a lot of self-organization, a lot of cell movement, and the way I kind of investigate how shape takes form is through genetically engineering stem cells to perturb the developmental processes that turn us into what we are. And so basically what that means is I play with DNA within these cells to make them move differently.
Yeah, so when I visit the lab, Catcher showed me this particular protocol that he was working on for heart cells. And then basically he was able to manipulate it so that it was moving in different directions, and then it was actually beating like a heart. I got goosebumps looking at that, and then I really wanted to recreate that experience. So basically this real life interactive piece will bring to life the dynamic and intricate process of synthetic morphogenesis, and then allowing everyone to manipulate cells like scientists does. So basically the camera will capture your hand motion, and then that will be reflected on the simulation
of fluorescence imaging on screens as cells stretch, divide, and merge into complex structures. And then it was also inspired by Catcher's metaphor of EDM music, which is his research, which is like both chaotic and beautifully orchestrated. So this installation synchronizes music beats with cellular moment. And then I want to simulate the rhythm of life itself, its success, failure, and the continuous process of cell reorganization.
Okay, I don't think my researcher is here, but hi, my name is Hannah, and our immune system is designed to protect us with specialized cells constantly fighting off threats, including cancer. And Dr. Evanthea Torres studies how tumors often recruit the wrong type of cells that actually suppresses the tumor instead of fighting against it. And her research focuses on reprogramming or eliminating these suppressive cells to make immunotherapy more effective, especially specializing on breast cancer. And this artwork that I created, it's an interactive piece, and it uses double exposure imagery to visualize that hidden battle. So there's glasses that you could use, but through the blue lens, you would see the normal immune system. But then when you see it through the red lens, and you would see the reality of the suppressing cells that will actually be suppressing the tumor. And my piece invites you to experience the groundbreaking research that could help tip the scales in cancer treatment. Thank you.
On behalf of both of us, it was a great experience again. We're excited to have you all here. Dr. Schaff, would you like a closing comment?
I just want to say I am just blown away by the creativity of our scientists and the artists who represented their work. And I'm so grateful for the collaboration. Thank you for helping make it possible. Thank you for dreaming this up. And I hope everyone will continue to enjoy the art and the food and each other. So thanks for being here.